So for number 6, we have this. Does anybody have any ideas for what to do for this? Not a clue? Not a clue. Really? Make two integrals. We can get that, right? That's just normal antiderivative. That would be x squared negative from 0 to 7. So what is that? Negative 49. I have the plus. So really all I need to do, is that right? Any questions on that part? No questions. So then, how do I do that integral? There's two ways. One of them is to graph, and then find it by using areas. The other one is to make it into a piecewise function, and then do two more integrals. Which would you prefer? Okay, I'll do it both ways. So first, by graphing. So my problem then is going to be this. And then it hits the x-axis. Well, it's positive 2. Where's 0, 3? And that should all be eventually positive. Is that right? Is that what that line is supposed to look like? And then we make it absolute value. What? I found the x-intercept of this. So the question was, how did you know it hit the x-axis at 3? I was just finding the x-intercepts. To find the x-intercepts, you make y 0.
Yeah. Oh, there we go.
So then x equals 3? Yeah.
If you didn't know, not look at it like that, can you just simply know how the graph looks like if you plug in the x values into that equation?
Yeah. You were saying, can you graph it by plotting points? Is that what you're? Yeah. You can always graph by plotting points, as long as you know how to plot or plug in stuff. So we have this, but then the absolute value changes this graph so that it looks like up to 6 here, and that means I go 1, 2, 3, also up to 6. I'm going up to 7, so I need to know where this function is at 7. So I'll plug in an x value of 7. And I'll get out, 14, 13, 12, 11, 10, 9, 8. So right here is 7, comma 8. 1, 2, 3, 4. Yeah? We okay? So we're finding this area and adding it to this area. Because it tells me I have to go from 0 to 7. And when I plug in an x value of 7, that's how high I get. Right? I don't know if you meant x values or y values, but there you go. So then this one would be 1/2 times 6 times 3, which is 9. Plus 1/2 times 4 times 8, which is 16. Which is 25. So negative 49 plus 25. That would be what? 9, 4, 2, negative 24. Is that right? Cool. Any questions on that? Yeah. Josue, can you turn off one of the lights? So that was by doing areas. The question was, you have the absolute value of 2x minus 6. How come you couldn't just get the antiderivative of that and then do it normally? The question is, the problem is, this graph does two different things. So it's going to have two different antiderivatives. That's doing the piecewise part. We're going to, yeah. So here I can't just take the antiderivative of this because the antiderivative of that from 0 to 7 is different in two different spots. So I'm going to have two different antiderivatives. Yeah? How do I know that? Because I'm a math teacher. To do the piecewise part, let's see. We have the integral from 0 to 7 of the absolute value of 2x minus 6 dx. The question was, how do you know where this function changes? Or like where you make it use the other thing, right? Make you use the other. It's where this function. Well, the way we thought about it before was for this. For what values of x does the absolute value actually do something? You guys remember thinking about that? Do you remember me saying that at all? Where does the absolute value of x, or where does the absolute value do something?
When it makes it negative.
When the inside is negative, right? So we got to think, when is the inside negative? Because the absolute value is going to change it to positive.
When it's less than 6.
Less than...
Like whatever you plug into x that makes 2 times whatever it is less than 6.
Whatever makes 2x less than 6, that's true. But this is the way I'm thinking about it. When is this part, the inside, when is that smaller than 0? Because that's negative, right? So then I can just write 2x minus 6. When is that less than 0? I'll solve. So anytime x is less than 3, the inside is going to be negative, right?
So we could do this instead of having to graph it.
Yeah.
That was a more specific way what I was trying to say.
So do we understand that the inside would be negative when x is less than 3?
Yes.
All right, so I'm going to write a function, a piecewise function, that says I actually have some kind of function for x less than 3. And the inside's negative, right? If x is less than 3, the inside is negative, correct? Then the absolute values change it to a positive, yes? All right, so instead of using absolute values, I'm going to use parentheses and a negative. We've done this before. So this is doing the exact same thing as the absolute value is doing, right? And I know that this inside part is going to be negative because I'm telling the function to only use this when x is lower than 3. Then I need to make my other part. If x is bigger than 3, or equal to, just to make it continuous. If x is bigger, you could have the equals part on either of them because they both act the same way during 0, or when the inside is 0. So if x is greater than or equal to 3, the absolute values don't do anything, right? Because the inside will be positive. So then we don't need absolute values. We don't need any parentheses. Are we okay?
Yep.
So when x is smaller than 3, f of x, this function, acts like this line. When x is bigger than or equal to 3, it'll look like that line. Then to integrate this function, you just do from 0, you have to split up your integral. Instead of 0 to 7 now, you do 0 to 3. Which function am I going to use? The top one, which is just what? Because my x values are smaller than 3. Yeah? I showed you this before. So we have that plus the integral from what? Well, we end at 7.
Oh, my bad. Sorry, 3 to 7.
3 to 7. And that's just regular 2x minus 6. these integrals calculate exactly these areas. Do I need to do the I mean, now we can do the antiderivatives, right? Do you want to see that? I'm not going to keep making this video though. It's too long.